Welcome to the video tutorial for Unit 9, Day 2. This covers pages 5, 6, and 7. If you were absent on Day 2 of this unit, you're not going to understand this as well. We covered this a lot in class, so you'll need to get your notes as soon as you get back. But I've already started it. It says label the phases on the diagram to the left. Okay, so remember it's pressure on the y-axis and temperature on the x-axis. And so at a low temperature and low pressure, that's where we tend to have solids. Okay. At higher temperatures, that's where we tend to have gases. And so it goes in order: solid, liquid, gas. And then I circled the triple point. The triple point is just where those three lines intersect. This line meets this line meets that line. Okay. So the triple point is the combination of temperature and pressure where solids, liquids, and gases can coexist. So I did this one, I did A, and then it asks me what's the freezing point at 1 atmosphere of the substance. So remember, freezing is when I'm going from a solid to a liquid. So it's going to be the line between these two. The freezing point equals the melting point. But at 1 atmosphere, that's why I drew this line over, it's right there. There's the boundary between solids and liquids. So that's the freezing point and the melting points. But it asks you, what's the temperature? So I'm going to come down and it looks like it's basically 100 degrees Celsius. Okay. Now it's asking me what's the pressure of the triple point. And remember, this is the triple point. We circled it. Okay, I'm going to come over, and it looks like it's halfway between 0.50 and 0.75. Okay, so halfway between 75 and 50 is about 62.5. So I can say 0.625. Okay, and we're just estimating at this point, right? And then we're going to say ATM. Atmospheres, because that's the unit they gave me on that axis. D says, what's the temperature at the triple point? And the temperature, it looks like it's maybe just a little bit less than 100, but I'm going to go ahead and just say 100 degrees Celsius. At the critical point, and this isn't one we talked about much in class, but this is the critical point. After this critical point, then everything is plasma. Okay, and that's hotter than a gas. We usually don't worry about that too much. But after the critical point, then it's always plasma. And we'll talk more about that in physics than we do in chemistry. F, we need to be graphing. It says assume a substance is at 1.5 atmospheres and 0 degrees Celsius. So I'm going to graph that point. 1.5 atmospheres and 0 degrees Celsius. That's right there. Then it says if the pressure is lowered to 0.25. So instead of being up here at 1.5, I'm going to bring it down to 0.25. My pressure is going to come here. It's asking me what phase change would occur. Well, when I started, I was a solid, and after I lower the pressure, I become a gas. So a solid turning directly into a gas, remember from our notes, that phase change is called sublimation. Phase changes like melting, boiling, freezing, condensing, those are easier, but remember sublimation was one of those weird ones. Okay. Down here at the bottom half, we also did this in notes today. Okay, I asked you to, it's the heating curve of water in this case. So here I have cold ice, warm ice, right, relatively. This is where my phase is changing. So my solid ice is melting into water. Once all of it's melted, then the liquid temperature comes up until it gets to the boiling point of water. Then it's either it's boiling or evaporating in this direction, and then it's a gas. So I labeled this part right here is the solid, this part right here is a liquid, and this part right here is where it's a gas. B says label the following points: melting, boiling, condensing, and freezing. So moving from a solid to a liquid this way, that's when it melts. And I'm going to use a different color just so it's a little more clear. M-E-L-T. That's the melting point. If I go this way, that would be freezing. Okay, that's going from a liquid to a solid if I'm reading the graph backwards. So moving this way is when a liquid turns into a gas. That is boiling, which I'm going to say boiling, but actually I'm going to write evaporating. Okay, when it boils, it evaporates, so it's the same. And if you read the graph backwards coming this way, a gas turning into a liquid, that would be condensing. So we're labeled. Which area is the least dense? So it's asking you solid, liquid, or gas. Gases are the least dense. Okay, it says if heat is taken away at position D, which is right here. So if I take away heat, now remember heat is down here. So if I'm taking away heat, that means I'm moving this direction on the x-axis. This is what phase change is happening. And we already labeled that. Moving this way at point D is condensing. So go ahead and write that down. If heat is added at B, again, so adding heat means moving this way. Take a look at that. What temperature is the freezing point? The freezing point will be right there. Okay, that's the temperature that it freezes. How much energy is added to evaporate the substance? Now this is kind of a weird one. I don't think we'd ask you this one in the notes. So this is how much energy is added. So we went from 800 to 3200. Okay, if you follow that down, 800 went to 3200. So we can look at this and take our final energy, 3200 minus 800. So the energy that it took, the energy difference was 2,400. And that unit right here, it says kilojoules, kJ. What temperature is the freezing point? We already did that one, didn't we? Oh, I must have read it weird. Oh, I just wrote that in the wrong spot. I'm sorry. That's why. I was confused. What changes during a phase change? So during a phase change, the temperature is not changing because the slope on this line doesn't exist, right? So here we have a positive slope, here we have no slope. So what changes during a phase change? Not the temperature, just the state. And you can also say the energy. But temperature does not change during a phase change. Okay, so I did this whole page just because if you were absent, you wouldn't know otherwise. Okay, make sure you're getting the notes for those of you who are absent. Let's look at page 6. The top of page 6, it's asking you units for specific heat. Now, I've got that written there, but that's just because it's written here. C equals specific heat, and that's joules per grams degrees Celsius. Let me grab a calculator, and then we can take a look at some of the stuff on the bottom. So this is our equation right here, Q equals mc delta T. That's the equation that's written on the back of your periodic table. Your periodic table also tells you that Q is heat energy, and its unit is joules. M is mass, the unit's grams. C is specific heat, units right there. And delta T is the change in temperature. Now be careful with this one. You have to do the final temperature minus the beginning temperature. Sometimes that might be negative. Okay, so just make sure you're being careful. Number 2, you're starting to look at this table of specific heats. And you'll notice it's going from high to low or from big numbers to low numbers. So specific heat means joules, which is energy. So energy, to raise 1 gram of something 1 degree Celsius. So if it's a big number, it means it takes a lot of energy to heat lithium up. If it's a small number, it means it doesn't take a lot of energy to heat gold up. So it's asking us which element's temperature will increase the least when you give it heat. So because lithium takes so much energy, I have to give it a lot of energy. So it's not going to get very hot very fast, but gold will heat up quickly. So you also need to write me a because here. Okay, lithium and then because. Looking at number 3, Mrs. Holmes' students, I always make you box in your givens like this and circle your unknowns. Okay. Now the equation is Q equals mc delta T. So that's energy or heat equals mass times specific heat times the change in temperature. So I've got 4 things here, which means I need 4 things up here. I have 3 givens and 1 unknown. Right? So I can look at what we have. 80 grams is my mass, because grams is mass. Joules, remember up here at the top of the page, it tells you that joules means energy, and that gets the letter Q. So I'm going to plug this one in as Q here. This is my starting temperature, so T initial. This is my final temperature, T final. And in order to find delta T, I have to go the final temperature, which is 50, minus the initial temperature, which is 20. So my delta T equals 30 degrees Celsius. And it is a positive 30 in this case. So I have a delta T, I have an M, I have a Q. I don't have a C. I circled my unknown. So in this case, I'm going to put it in red. That's what I'm looking for. I'm looking for C. So you can copy that down here. You have to show work for credit on this. I am telling my students they may not do anything until they solve for the variable. So until C is by itself, until I do algebra to get C alone, I don't want to plug these numbers in yet. Okay? So right now I have Q equals mass times specific heat divided by temperature change. So in order to get C by itself, I have to unmultiply by M and T. And the opposite of multiplying is to divide. So if C is being multiplied by M, I need to divide it by M. That would make it go away. If C is being multiplied by delta T, I need to divide by delta T, because that makes it go away. And now C would be all by itself. If I do it to this side, though, I have to do it to the opposite side of the equation. So I'm also dividing this by M delta T. So then I have C equals Q over M delta T. Be careful when you plug in these numbers. Please excuse my dear Aunt Sally. You have to multiply the bottom in parentheses before you can take the top divided by the bottom. Your answer should be less than 1 on this. So when you find this answer, it should be 0 point something. Okay? If you didn't get it, just check your work in your calculator.
Okay, do that.
Alright, let's look at number 4 in the back. Number 4, I've already boxed in my givens and circled my unknowns. Okay? I'm going to go ahead and write them down here as well. It's asking me how much heat energy is required. So the one of these that is heat energy is Q. It's asking me to find heat energy. So I'm just going to put a question mark there. I don't know what that is. Do I know what my mass is? Yes, they told me 40 grams. So I'm going to write 40.0 grams. It told me the water's going from this temperature to this temperature. So I know my initial temperature is 28.5. My final temperature is 98.5. So in order to find delta T, I go final minus initial. So this equals 98.5 minus 28.5. 98.5 minus 28.5. 70 degrees Celsius is my delta T. And my specific heat, it says, is 4.18. Okay? I don't have to do any algebra on this problem, because I'm looking for Q, and an equation already has Q by itself. So remember, algebra is rearranging that. I don't have to. I can just plug it in. Q is already by itself, hip hip hooray, times M. And I know M is 40.0 times C, and I already labeled that C was 4.18, times delta T, which I calculated to be 70. Okay, now it's this times this times this. I'm going to go ahead and put that in the calculator. 40.0 times 4.18 times 70 equals Q equals 11,704. And the unit for Q, remember, it's on the back page, or on page 6 if you need to check, is joules. So please make sure you're including joules. Alright, let's look at number 5. It says a sample of water absorbs 3010 J. So you need to know from your notes that J is what we use to plug in for Q. So they gave me Q. They're telling me the temperature increases from this, which means it's my initial temperature, to this, which means it's my final temperature. So I'm going to say final 44 minus my starting, my initial, equals. And that would be 9, positive 9. So 9 equals my delta T. I've got that. They're asking me for the mass of water, so I don't know M. That's what I'm solving for this time. And they do tell me C, specific heat. So I always start by writing the equation down. Okay? And then I'm either going to circle or underline, in this case, make it red. I need to solve my equation for M. That's what I'm looking for. So in order to get M alone, right now I have to do the opposite of multiplying it by C, which is dividing it by C. So that goes away. M is being multiplied by delta T, so I need to divide by delta T. So if I do that, then M will be alone, which means I need to do the same thing over here. C delta T. So then I can rewrite it, so just so it's clean, M equals Q over C delta T. Sorry, my little minion in the background. Now I can plug it in. M equals Q, which is 3,000, I already labeled it, 3,010, over C, 4.18, times delta T, which I found was 9. Okay. Now watch how we put this in the calculator. 3,010 divided by parentheses, 4.18 times 9, close parentheses. So my mass would be 80.0. So I'm just going to say 80 grams. M equals 80 grams. Like that. Now, careful, if you didn't put parentheses in your calculator, if you just did 3,010 divided by 4.18 times 9, you get 64,000. That's not right. Please excuse my dear Aunt Sally, okay? My dear, I have to multiply before I can divide. So the parentheses cleans that up for us. Okay, 80 grams. Okay. You should solve number 10 on your own. Box in your givens and circle your unknowns just like that. Alright, good luck. This is a lot on the test, so make sure you're ready. If you need extra help, come in for tutorials before test next week.